Hey, this is Lyle Dodge. We're back with Azure and Enterprise. Today we have Roberto. Hey, nice to see you.
Hey, thank you, Lyle.
And we're going to
Here,
talk today about some stuff from your customers around high availability in AKS, right?
right. I'm actually, as a cloud native technical specialist, I used to face a lot of customers working with AKS and some microservices architecture and cloud native architectures in Azure. And one of the things that today we are going to see very fast is how can I take decisions and how can I make good practices to continue this high availability practice ongoing. One of the things, go ahead.
No, go ahead. Let's get dive
Ah,
right
okay,
in.
awesome, awesome. One of the things that I would like to share right now, let's see this whiteboard. I'm going to draw some simple architecture. We have here my application. I have an application that is connected to a load balancer. This is a pretty simple application. We have the load balancer, and our load balancer is connected with our AKS cluster. This is our AKS cluster, and we have here our ACR, or container registry. This simple scenario that we have here, we have everything in one single region. In this case, we have everything here in just one single region. One of the first things that we need to consider here when we are working with AKS in Azure is try to figure out how AKS works. AKS has two components. The first component is the master node. The master node is responsible to orchestrate, for example, we want to scale or deploy our nodes or in our cluster. This is important because it's the core, all the core services in Kubernetes. This is something that we don't manage. It's something that Azure manages for us. And the second thing that we need to consider here is the worker nodes. The worker nodes are the nodes that we are using to run all our application workloads. This is something pretty straightforward in order to see in a virtual machine scale set or virtual machine running connected to Kubernetes. So how can I think that, how can I plan that this is a good strategy to make high availability? Well, I need to think in two things, my master node and my worker node. For this scenario, one of the good practices here is to make, for example, if I'm going to production, I can consider availability zones. What is an availability zone? An availability zone is a specific physical location in a region. For example, if I have my region, let's see, I have the region 1. In this region 1, I can specify in 1 or 2 or 3 zones where I want to be deployed my nodes. In this case, if I select the location 1, 2, and 3, what is going to happen is that my master nodes and my worker node are going to be deployed on this physically location in one single region. This is something that is good in order to make some redundancy inside of a region. This causes more availability and helps us to mitigate any possible failure from the Kubernetes side. Another thing that is important to consider here is that if we are running with this kind of service, we can get a 99.95% of SLA using the masters. And if we are not using this service, we are running on 99.9% of SLA. How can we validate this? If we want to share see more information about this, we can check directly in the SLA or for Kubernetes. This is a pretty cool website where we can get all the latest information of Kubernetes. If we want to see how Kubernetes SLA is updated, this is the very recent update. And if we want to get more information about availability zones, we can get more information in the Azure documentation to get more understanding about how can we implement Azure availability zones. This is something that is not only applies for Kubernetes, also applies for any virtual machine that we are running. This is one of the considerations that we need to have when we are designing a simple application. The second thing that we have here is that I'm working with two applications in my cluster. Let's say that we have an API. Let's draw here, like I have an API, and by the other service, I have, I don't know, a database. It could be MongoDB, or it could be MySQL database. I don't mind right now. But at this point, I have two services running in my cluster. So this will change the behavior about what I'm going to do, because I need to have two treatments in our services. It means I have stateful services and I have stateless services. What it means, stateless services, I don't need to back up and restore any particular state. And if I have stateful services, it means I need to figure out how I need to back up that state, and I need to put it again. One of the things that we need to consider here are the points of failure that our architecture has right now. What are the points of failure that our architecture has right now? Well, the first one is we are running in just one single region. The second one, we are running just one single cluster. The third one, I'm running just one single container registry. So one thing that we can do to mitigate the AKS cluster point of failure, well, we can use availability zones, as we mentioned it before, but this is not the only thing that we need to consider here. The second thing that I need to consider is how I'm going to treat my services and my application that are running inside of my cluster. The second thing that we need to consider here is, for both scenarios, we need to think about have pipelines to easily deploy our applications. Our application could be containerized, and we can have a Helm chart, but also we need to have a pipeline to deploy automatically. We can use Jenkins, we can use Azure DevOps, we can use GitHub Actions, but we need to have in mind that we need to have this in an automated way. The second thing that we need to consider here is an automated way to deploy our cluster. What's happened if our cluster becomes compromised? And for example, I deploy some configuration that damage our cluster, or someone that doesn't have any experience in Kubernetes took some information there and cause any damage in our cluster. We need to redeploy it or create a new one in another location. I don't know, but we need to have a very fast way to have our cluster put again. And one of the things that we can do to mitigate that, we can use Terraform, we can use, for example, Azure CLI Bash, or we can use, for example, ARM templates. There are many options to recreate our cluster. This is something that it doesn't matter if I'm using a stateless or I'm using a stateful. I need to have both scenarios considered on this. Another thing that I would like to mention here is what happens if I'm working with databases or some application that need to handle states. I need to understand what kind of a state this application is using. And in order with that, I can see what option do I have. For example, let's think that I have, for example, Azure Disks. Or if I'm using Azure Disks, I'm saying Azure Disks because if I use Azure Files, it's easier in order to create a snapshot of the Azure file, and we can put it again in a specific time that I need it. And if I'm using Azure Disk, it's more complex scenario. What it means, if I'm using Azure Disk, there are no Kubernetes native solution to do that in Azure. So we need to use some tools over cloud native tools. For example, we have Eptio. Eptio Arc is one cloud native tool that is pretty amazing to do this kind of backup and restore strategy. What it means, imagine that I have an application running. This is my MongoDB database in Kubernetes. This is a specific namespace. I need to take a snapshot of that backup for that namespace with my application running with all the information that I have, and I need to store it in a blob storage. And every time that I need that information, I can take, using FTR, I can take that state from my blob storage and I can put it again in my Kubernetes service. This is something pretty amazing because FTR is Kubernetes native. And this is a good strategy that we can consider in order to make some backup and restore strategy. The second thing that we need to consider here, this is one of the most important things here, but the second thing is I'm working with just one single cluster. What's happening if this cluster becomes compromised and I need to redirect the request to another cluster to have high availability here? So I can do another strategy. The second strategy here, or the next strategy, is multiple clusters in one single region, What it means that I'm going to continue using this region. For example, I have again my application. And my application now, since I'm going to route in a more global way, I'm not going to use a load balancer. I'm going to use a traffic manager here. My traffic manager will allow me to redirect the request that I want to use. So I have here my load balancers. One thing that is important for availability zones, we need to consider standard load balancers. As most of the time when you create a load balancer, it becomes like a basic load balancer, but particularly for availability zones, we need to use a standard load balancer. So at this point, I'm going to use a standard load balancer, thinking that I have availability zones in my Kubernetes cluster. So right now I have here my Kubernetes cluster, but checks, for example, this case. I have my two clusters. I'm going to create another standard load balancer. I have here my AKS cluster. But one of the things that I would like you to see here is that I'm excluding at this point my database from my cluster. What it means, I'm putting outside my database here. So I'm going to create, for example, this is something that we need to consider when we want to create some reliable solution. If we need to rely on backing services, what it means, not everything needs to be handled in Kubernetes. We add some more complexity layers to make some synchronization between clusters, to manage states inside of the cluster, manage disks. So if we want to create more economic and simplistic scenario, we can use, for example, an external database. For example, we can use here Cosmos, or in case I'm using, I can use, for example, Atlas, or I can use, for example, MySQL. Let's do something like this, MySQL. So at this point, I have my database here. This database that I'm creating is working in two ways. What it means, I can write and I can read. This is something that I can have this in mind. The second thing that I'm going to do here is that I'm going to create my ACR. My container registry now is going to provide the images that I'm going to use to two clusters. It means I have one cluster here and I have the other cluster here. This is something that this can help me to manage the deployment in both clusters. And by the other hand, I can have here a second database. And this database can be, as I mentioned it before, it can be Cosmos, Atlas, MySQL, but the difference is that this database will be just only for read. What I'm doing here is that we can have some kind of synchronization on geo-replication to make all my data synchronized, and we are going to use just one case for one database for production. Imagine that I have this scenario. This scenario is running just in one single region. I'm going to take everything here, and this is something that we can do in one region. With this scenario, we are mitigating possible failures in our cluster, but we need to consider, to have in mind that there's another single failure point here. And the other point of failure that we have here is the region. We are working in just one single region. What it means? That if I'm working in one single region, if this region it becomes compromised, so it became compromised here, so all my architecture, all my infrastructure, and all my solution can be compromised too. So the third and the last scenario that we are going to share here is, well, what happens if we create multiple clusters in multiple regions? So to make this architecture is very similar to the other ones. I'm going to put here, for example, my application, and my application will use my traffic manager. This is my traffic manager. And in this case, one of the things that I'm going to do is that I'm going to call, for example, here, let's see, okay, this. Okay, in this scenario, I'm going to have, oh, let me change my color. Okay, awesome. In this scenario, what I'm going to have here is my standard load balancer. Let's put here my standard load balancer. And another thing that I'm going to do here, I'm going to add my cluster. I have my AKS cluster. My AKS cluster is running my API. This is the stateless service that is running inside of my cluster. And outside, I have the database that I mentioned before, where we can create some write and read properties to think on that. And I have here my ACR. But all this configuration is running in just one single region. In this case, what I'm doing, I'm going to specify here that this configuration is just for the region 1. And this configuration will allow me right now to have everything up and running in just one single region. Now, let's do the same thing with the next region. I have here, let's put here, for example, my load balancer. I have my cluster, my AKS cluster. I'm going to put here my database. I have my read database. And I can have here some kind of synchronization of geo-replication between two regions. And also I can have my ACR with geo-replication. It means that I can have multiple container registries in different region too. So with this architecture, what I'm doing, I'm mitigating the single point of failure that I have in one single region. So in this scenario, if one region is compromised, I have the traffic manager that is going to be aware about possible issues that we have in one region, and automatically it will redirect all the requests that we are going to have. In this way, we can do it manually or we can do it automatically. Remember that when we are using Traffic Manager behind the scenes is sending requests, small requests to our endpoints to validate that the endpoint is working as expected. In case we don't receive any any feedback or any response from that endpoint, automatically Traffic Manager is going to reroute or request to the next region that we have, in this case to the next endpoint that we have. We have two endpoints here. We have the endpoint 1 for the traffic manager, we have the endpoint 2 for the traffic manager, and with this scenario we have more isolated concern. So in this case, if an ACR or one region or one cluster becomes compromised, we don't have any issue. We can add more complexity on this architecture in case we want to have more redundancy in one single region. Remember that we have here this database. This database is for just reading, but we can do the same inside of our region. Imagine that we have another database here, and this database is for read, and we can have more redundancy here between these databases, and we can make some synchronization between these both databases. This is something that we can also do. I'm trying to keep it simple with just one database in each region, one for writing and reading, and the next one is for reading. And these are these are the practices that I used to see with our customers, and this is something that I really want to share with the team. Thank you, Lai.
You're welcome. I have a couple of questions. So, in some of these designs, when you're looking at the different aspects, where do you make the trade-off of running the database inside of the cluster versus using Azure native, like manage Postgres, or where are there spots where maybe you see customers using kind of like upstream or incubating projects out of the Kubernetes ecosystem in addition to or instead of some of our first-party stuff?
Well, one of the things that I have seen is that Kubernetes is a monster. It's big. So to get the full understanding on about how Kubernetes works, it means the operation teams need to be aware how to manage whole infrastructure in Kubernetes. So one of the things that I realized is that it's easier for the customers to move to some service managed service to handle whole the complexity that we have inside of the cluster. For example, if I want to write directly and have her replication, I don't need to care about what's happening if my container. Remember that everything that is running in Kubernetes is just one single pod. What happens if that pod fails? If that container fails, I need to have a lot of strategies inside of our cluster. It's not bad. It depends on the team, of the maturity of the operations team. If I have a customer that has a high maturity on operations in Kubernetes, so let's do it inside of the Kubernetes cluster. This can be a very well project using a database or a stateless inside of Kubernetes. It has advantages. But when the customer maturity is not too high, one of the suggestions is, well, you can move it to another managed service, and it will be easier for you to have all the complexity fluid in multiple services across Azure.
Awesome. Thanks for that. Well, Roberto, thanks for your time today. We really appreciate it. I think we'll have some more from you guys before too long.
Thank you, Lai.
All right. Have a great day.
Bye.